Chapter 5. Review. Solve the system linear equation using any method. So remember, the two methods that we've learned have been substitution and elimination. You see, in number 1, the best one will be to use elimination because we already know that negative 5 plus 5 will cancel out. If we add this, we have 3x plus x gives us 4x equals negative 20. Divide by 4, x equals negative 5. With having already 5, negative 5 for x, we're going to use substitution. You could use any equation. We'll use the first one, which gives us substitute x for negative 5 minus 5y equals negative 30. We're going to add our constants to the same terms, which gives us, cancels out, gives us negative 5y equals negative 25. If we divide by negative 5 to both sides, we're left with y equals positive 5. Therefore, our answer is going to be negative 5, 5. In number 2, you also could decide between substitution or elimination. I will use here elimination just because I could see that the 2y are both positive, but I could turn one into a negative, so it just could cancel out. So I'm going to multiply my first equation times negative 1 to give me negative 1 times x will give me negative x minus 2y equals positive 3. If I'm to add all this, I will have this canceled out and be left with negative 6x equals 54 divided by negative 6. I'm left with x equals negative 9. Using substitution, I will use my first equation where I'm left with negative 9 plus 2y equals negative 3. I'm going to add 9 to both sides, and I'm left with 2y equals 6 divided by 2, y equals 3. Therefore, my answer would be negative 9, 3. In number 3, we have another method that we could again use will be elimination. If I multiply my first equation by positive 2 to cancel out the 10, I will have negative 10x minus 8y equals negative 30. As you can see, they all basically cancel out. We have cancels out 10x minus 10x, 8y minus 8y, which gives me 0, and 30 minus 30 gives me 0. This solution will be infinitely many solutions. Number 4, if I already have one in a slope-intercept form, that's the best time to use will be substitution. So I will substitute wherever I see y on my second equation. In this case, I will substitute. Remember to always use parentheses so you could distribute properly. We're going to have negative 4x plus 2 times 2x plus 3. Remember, we're grabbing it from here. That's the substitution. Equals 8. If I use this distribute correctly, I know it's a positive, but it's always easier for you to put it in parentheses. I'm going to be left with negative 4x plus 4x plus 3 equals 8. If I combine my like terms, I know that negative 4x plus 4x cancels out, and I'm left with 3 equals 8. This is not a solution. Therefore, this is no solution. Number 5. Again, we have a slope-intercept form, so I will use substitution. I will have 2x plus, again, parentheses, negative 5x plus 6 equals 6. I would distribute. I'm going to be left with 2x minus 5x plus 6 equals 6. Combine my like terms where I'm left with 2x minus 5x gives me 3x plus 6 equals 6. Combine my like terms, I'm going to be left minus 6 on both sides. Negative 3x equals 0. Divide that by negative 3. Let me rewrite 3 better. This negative 3 cancels out. I'm left with x equals 0. Substitution again. I'm working for y. So I will use this slope-intercept form equation, which I'm y equals negative 5x times 0 plus 6, which is y equals, this cancels out, 6. My answer is 0, 6. Number 6. This is not in slope-intercept form, but we have an x equals. Again, this is easier to use. Substitution, just wherever you see x, substitute for this first equation from the second one. So we're going to have negative 5 times negative y minus 1 plus 2y equals negative 65. I will distribute, which I'm left with. Negative 5 times negative y gives me positive 5y plus 5 plus 2y equals negative 65. Combine my like terms, which is 7y plus 5 equals negative 65. Move over my 5 by subtracting it so it could cancel out. I'm left with 7y equals negative 70. Divide by 7, y equals negative 10. Substitution, now I'm looking for x, correct? So I will use this first equation, which is already telling me x equals negative times negative 10 minus 1. X equals 10 minus 1, which basically means 9. My answer is 9, negative 10. Number 7, we're going to graph the inequality in a coordinate planes. So again, like I told you before in school, if you have y, you're going to have what type? A horizontal line. If you have x, you're going to have a vertical line. This is only when y is by itself and x by itself. You have both variable x and y, you're going to have either a positive or negative line. With that being said, remember the rules. You're going to have first, you're going to graph your line, decide whether it's going to be a dash or solid. Best way to remember is if you have a line at the bottom of your inequality, it means solid. If you do not have it, then that means that you're going to have a dash line. Number 2 is use a test point, and 3, shade. So here we have y is greater than 0. I already know that y is going to be an horizontal line because I do not see any x. So I'm going to have a horizontal line across, across the x-axis because it's going to be 0. Now this I graphed it. I know that it's a dash. Now I'm going to use a test point. Do not use a test point of 0, 0 when it's in the what? Boundary line. In this case, we can use 1, 1, which is right over here. And if I test that point, we already know that 1, 1, we have x and y. If I substitute here for for y, I'm going to have y is greater than 0. Is this true? Correct. Therefore, you're going to graph where? You're going to graph where you tested the point. In this case, it's going to be right over here, up here. And this is it for number 7. Number 8, we're going to have 2x minus 5y is less than or equal to negative 10. First thing I'm going to is put this equation in slope-intercept form, which I'm left with. If I move over my 2x across, I'm going to have negative 5y is less than or equal to negative 2x minus 10. I cannot have a number in front of my variable, nor it be negative, so I'm going to divide by negative 5 to all my terms. We divide that, I'm left with y is now greater than or equal to, because I divided by a what? By a negative. Gives me 2/5 x plus 2. Now I'm able to graph this. We know my y-intercept is what? 2. So I'm going to have my first point here, and my slope is up to 5 over. So I'm going to have 1, 2. This graph is smaller, but I know it's going to be somewhere around here. And I'm also going to go backwards, which is down 2 and over to the left 5. 1, 2, 3, 4, 5. It's somewhere around here. I have a line under my inequality, so I know it's going to be a solid line. Let me redo this solid line a little bit nicer. So now I'm going to use which test points. Remember the rules. 1, graph, determine if it's dashed or solid. 2 is to use a test point. I'm going to use the test point for 0, 0. So if I plug in 0, 0 to my equation, my inequality, I'm going to have 0 is greater than 2 times 5 times 0 plus 2 gives me 0 is greater than 2. Is this correct? No. Therefore, you're going to graph the opposite area where you don't have your test point, which is specifically right on the above over here. Number 9. Now we have graph the system in linear inequalities. Now we have 2 inequalities. Again, same rules. Graph, determine dash or solid. 2, test a point. 3, shade. What I would do is work with one inequality at a time. So here we know, let me use a pen. Here we know that it is not in slope-intercept form to graph. It will make it easier. So I will have 2y is greater than or equal to negative 3x minus 2. Divide by 2 because I cannot have a number in front of my variable. I'm left with y is greater than negative 3, 2 minus 1. I already have my first line. My first line, which is going to be a negative 1. Just right here, that's my y-intercept. 3 down, 2 over. 1, 2, 3, 2 over, and I'm going to go backwards. 3 up, 1, 2, 3, and 2 over. I'm going to have what type of line? A solid line. That's step 1. 2 is to test a point, right? I'm going to test, in this case, I'm going to test 0, 0. Again, it's easier when it's 0, unless it's not in the, unless it's in the boundary line, you cannot use it. So I'm going to have 0, 0. 0 is greater than or equal to, I forgot there's an x here, okay? Negative 3, 2 times 0 minus 1. Therefore, this is 0 is greater than negative 1, because this cancels out. This is true. Therefore, which area are you going to graph? Not graph, shade will be this area where your test point is at, because it makes it true. Line number 2, I have which one? Right over here. I'm going to have 2y to put it into what? Slope-intercept form. 2y is less than negative x plus 2. Divide by 2 to all sides. I'm left with y is greater than or equal to negative 1/2 x plus 1. I already know my what. So just imagine that you have nothing shaded, and then, so you cannot get confused. Then you'll see how it combines together. Just imagine there's nothing starting from as if your graph is completely empty. We know that it's my y-intercept is 1, which is right over here. My slope is -1 and over 2. 1, 2. I'm going to also go backwards, which is go up 1 and over 2. So I could see there's a point there that intersects. So, and I know my line is going to be solid because it's an equal to. There you go. So I need to determine now, test the point, number 2. I'm going to test it over here. So I'm going to have test 0, 0, because it's not within the boundary line. And I'm left with 0 is greater than or equal to -1/2 times 0 plus 1. Is 0 less than or equal to 1? Yes. So that means, again, shade where my test point is at. So my test point, I know from my red line, is where? Right on this area. This, as you can see, is the area that is the solution to that. All these points on this area are the solution to that inequality. But this darker right here where you see, let me point it out right here. This darker part right here where you see the intersection of both overlapping, all those points are the intersection where it is solution to both inequalities. Number 10, we have, again, both of them are in standard form. I'm going to turn them into a slope-intercept form. Work with one line at a time. My first line, I'm going to have -3y greater than or equals -2x plus 6 divided by -3. I cannot have any negatives next to my y, so I'm going to have y is greater than, I divided by negative, so flip your sign. Now y is going to be less than or equal to 2/3 x minus 2. I already have my first point, which is -2, which is my y-intercept, up to 3 over. And I'm going to go backwards as well, down to 3 over, and I have a solid line. I'm going to use 0, 0 for my test point. 0, 0, remember, it's easier as long as it's on your boundary because anything you multiply by 0 is going to be 0. So if you have 0 is less than or equal to 2/3 times 0 minus 2. Is 0 less than -2? Incorrect. That's not. Therefore, I'm going to I'm going to shade to the opposite of the test point, which is going to be right below the line. Line 2, I'm going to have, not line 2, inequality 2, I'm going to have 6y is less than or equal to 4x minus 18. Divide by 6 in all sides, I'm left with y is less than or equal to 2/3. I'm going to simplify it, my slope, just so it could be easier for me to count. 2/3 x minus 3. So my y-intercept is going to be -3, which is right here, up to 1, 2, over 3. 1, 2, 3, it's right here. And if I go backwards, I don't have space, but I already know the line is going to be down 2 and over 3. It'll be similar to right over here, and it's going to be also a solid. Test your point again, which I'm going to use 0, 0. It's not in the boundary line. 0 is less than or equal to 2 times 3 times 0 minus 3. 0 is less than or equal to negative 3. Is that correct? Incorrect. So I'm going to graph below, which gives me right down here. So that is going to be the overlapping points, this area right here. Let's move to number 17. I skipped 11 through 16 because there were word problems. We're not going to have word problems in our test. So let's just move to the next slide. Number 17 is the opposite of what we just did in the other two examples. But the difference is now we're looking to actually write a system of linear equality represented by the graph. We see here in number 17 two lines, correct? First, identifying the lines. I know I see here one line going this way, and everything here is the part that is shaded in, correct? That's the part that I already see that it's shaded in, so it's given to me. You want to have it in a y equals mx plus b format, same thing as the slope-intercept form, but in here we have just an equality. So the difference is the equal sign and the inequality. So I'm going to start with y. I know it is dashed, so because it's dashed, it's going to be a less than or greater than. This is shaded to the below the dashed line, so it's going to be less than. We already know that my y-intercept is positive because my line is positive. So it's going to be what? It's right over here at plus 3. We know we're going to have x. Think about if y equals mx plus b, and you're just plugging in numbers. We know we have a y, we have an x, and we have a b now. My slope is again positive, so I'm going to determine where is my next point. I see my next point is over here. So how much am I going up? I'm going up 1, 2 to the next meeting, and going over what? 2, correct? And we know that 2 over 2 gives me the same as just x. Therefore, because it's 1. So I'm going to have y is less than x plus 3. That's going to be my first line. My second line, I already see that it's also going to be what? Negative. Let me highlight it. It's going to be negative, and whatever is shaded is on this side. Correct? And I can see already the overlapping from the other shade. So again, we're going to start with y is dotted. It is shaded from that line to below or above. It's also below, correct? So I'm going to look for my y-intercept, which is all the way up here. So if we know this is 3, 4, 5, 6, plus 6, we know we have an x. And I know it's negative, so that means I'm going to go down. Let's look for now another point from the one up there, which was 6. The next point is going to be right over here, correct? So I'm going down 1, 2. That means it's negative 2 and over 1. This is going to be rewritten as y is less than negative 2x plus 6. And this is both of my answers to my inequalities of this graph. Number 18, we have two lines again. I have a solid and a dash. Let's start with our solid line, which is right here and going down. The only reason I know that it's going to be shaded downward is there is a darker area in the middle. That is where it's overlapping. It cannot go up above because then it wouldn't overlap with the bottom line, correct? So it needs to go down. Now I shade that part down all the way here, and there's no white spots, so I know that that is the whole graph is basically shaded in. I'm going to have it in y-intercept form, which is y. This is graph to the bottom, so it's going to be y is what? Less than or equal to, because it's below. My y-intercept is what? Plus 1. We know we have an x here. And let's figure out, and we know the line is positive, okay? The line is positive because it's going upward. Let's figure out our slope-intercept form. This is the 1, let me do this color. This is 1 for my y-intercept, and this is another point. So how much am I going up? 1. And running over, rising 1 and running over 1, 2, 3. So that's going to be my answer. Y is less than 1/3 x plus 1. That is my first for my solid. My second line, I know it's dashed, and it is graphed from this above. Correct? The dash makes it y is everything is shaded above the dash line, so it's going to be y is greater than my slope, not my slope, my y-intercept is negative what? That's -2. We know we have an x here. Let's find another point right over here. That means I'm going to rise 1 and run 1, 2, 3. So that means these are both what? My lines. And I know that both of my slopes are 1/3, so that means I'm going to have what? Parallel lines. That's a way of identifying. If you see two lines that are parallel, the slope has to be the same. Number 19, solve the equation by graphing, check your solution. So remember the rules. You're going to have two lines because they're equal to. Have them both equal to y equals, right? That's the rule. So we're going to have y equals 2x minus 3 and y equals x plus 2. This format, remember, it's the easiest to do what? To graph. Okay, I'm ready to graph. Let's center this a little bit. I'm going to have my first line graphed is going to be a y-intercept of -3, slope of +2, 1 up. You could do as many points as you want. The more point, the easier it is for you to do a straight line. Oh, why did it turn yellow? Okay, the second line is going to be a y-intercept of +2 and a slope of 1. So you can see where it meets, and I could go also backwards. As you can see, right over here in this corner, it's what it's meet, and it is when it meets, and that is going to be 1, 2, 3, 4, 5, right? 5 what? So we know we have 1, 2, 3, 4, 5, and y will be 1, 2, 3, 4, 5, 6, 7. Number 20, we already know it's going to be an absolute value. So that means that you're going to have two graphs and 4 lines. First line is going to be your first graph, I guess. We could do your first graph. Your first graph is going to be y equals x minus 1 and y equals 2x minus 5. And I can automatically already graph this Correct. My first line is going to be a -1. Y-intercept up 1 for my slope is at 1. That is my first line. My second line is a y-intercept of -5. 1, 2, 3, 4, 5, and a positive slope of 2 over 1, 2 over 1, 2 over 1, 2 over 1. So I could see already my what? Where it intersects, which is going to be right over here. That point is 1, 2, 3, 4. And y is 1, 2, 3. My second one for my absolute value, remember, that's just my one graph. So always remember, if you're just graphing with equal, with no absolute value, you're going to have one graph, 2 lines. If you are doing absolute value, you're going to have 2 graphs, 4 lines. The first line is going to be the same. Okay, we're using the same line. So it's going to be now y equals x minus 1. So if you see, same line. Second one is going to be y equals negative. So remember, in absolute value, you have anything that comes out of absolute value is always going to be positive. So you grab a -5 and it comes out 5. You grab a +5 and it still comes out 5. So that's why you're going to have 2. Negative times 2x minus 5. If I was to rewrite that, I'm going to have y equals -2x plus 5. And these are going to be both of my lines. This and these from both are going to be the same line. The only difference is going to be the second one. Let me just graph now. That came out really crooked. Let me turn my iPad around. My first line is at -1. Same thing, right? Except this graph is shorter. My lines are a little bit more. My origin lines are more to the other side. Now I'm going to do my second line. Second line, I'm going to do it now green. Because I know now it's a negative. So I have negative and +5 for my y-intercept. 1, 2, 3, 4, 5. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Let's see the intersection. Intersecting right at this point right here, which that gives me -2, +2, 1. Those are your answers. Number 21, like I told you, you do not need to do. I'm not going to give you an equation in that format. But do study the rest of the formats of the test and you should be good.